Okay, we're on page 192 looking at problem number 3. I'm going to try and fit 3 and 4 in this one video, but maybe we'll have to break it in two depending on how it goes. Okay, so problem number 3. Being as specific as possible, what type of figure is this, and prove it. All right, this problem always really annoys people because it so looks like a square, and it seems kind of like it would be assumed that it's going to be a square, but we can't assume it's a square. We have to look at the information that's given and not assume. All right, so let's take a look here. This has a lot of similarities to the last problem that we just did, the one where we were supposed to prove that RHOM was a rhombus after we found the missing ordered pair. So I'm saying it's got a similarity because in here the y coordinates are the same, right? Which means that this is going to have a slope of 0. And then we look here and we say, oh, well, yeah, the y coordinates are the same. So this also has a slope of 0. That means that these two sides are parallel, right? That's looking good because in a square we would have opposite sides parallel. But then we look at this and see x coordinates are the same for F and R. Therefore, this is a vertical line. It's going to have slope that's undefined, but what we'll notice then is that this does form a right angle. This does form a right angle because this is horizontal and perfectly vertical. So again, we're off to a really good start. One pair of parallel sides, one side that is perpendicular to both of these other two sides. And then we get over here and we get upset because this x coordinate is 16 and this y coordinate is 15, and therefore they are not vertical in spite of the fact that it's so close. They look very close right there. But this one's just over a tiny bit further, and therefore this is not going to have an undefined slope. It is actually going to have a slope that is a number here. So if we were to do that, we would have the difference of the y coordinates. So 4 minus negative 8 would give us 12 in the numerator, and 15 minus 16 would give us a negative 1. So this has a slope of negative 12. All right, 4 minus negative 8 is positive 12. 15 minus 16 is negative 1. So negative 12, whereas this is undefined. So this side right here is not perpendicular to these, which means these cannot be right angles, which means this cannot be a square. All right, so if it's not a square, what is it? So think about what shape that we know that would have one pair of parallel sides and two sides that are not necessarily parallel. Hopefully, as you're thinking about this, you're saying, oh, I think it's a trapezoid. All right, remember in trapezoids we have one pair of parallel sides. They were really mean here because, again, they've given us this shape so far, and then that one side right here is just ever so slightly off. All right, so, but just that little difference of this being scooched out just a tiny bit more is enough to change this from potentially being a square to a trapezoid. All right, it's definitely not going to be a square, so let's not try to prove that because we will end up failing. So we're going to go with it being a trapezoid. So again, I'm going to look at page 188 and I'm going to say, how do I show it's a trapezoid? And that is right down here. Show that one pair of sides are parallel and show that the other ones are not. Right? And in order to do that, we have to find the slope of all four sides because we're going to have to say these have identical slopes and these have different slopes. So let's do that. All right, so let's do the slope of FO. Oops, I almost wrote 5O. Slope of FO. So we're going to do the difference of the y coordinate, so 4 minus 4 over 15 minus 3. Going to give me 0 and 12, which is 0. And then the slope of RU. Difference in the y coordinates, negative 8 minus a negative 8 over 16 minus 3. Negative 8 minus a negative 8, this becomes negative 8 plus 8, which gives us a 0 over 13, which is 0. All right, it doesn't matter that the denominators that the denominators are different. What matters is that the denominators are not 0 and the numerators are 0, which means that both of these fractions are equal to 0. All right, so these two are the same, which is good. We've just proven that this and this are parallel. Okay, now what we need to do is prove that these are not the same. So let's take a look at the, FR. So slope of FR, right? Difference of the y coordinates. So I'm going to do 4 minus a negative 8 over 3 minus 3. 4 minus negative 8, that's the same thing as 12 over 0, undefined. Right, so all we need to do is show that this is not undefined, which we just kind of did briefly right here, and that'll do it for us. So slope of OU, difference of the y coordinates, so 4 minus negative 8 again, over 15 minus 16. 4 minus negative 8 is still 12. 15 minus 16 is negative 1, so this has a slope of negative 12. All right, so now we're going to summarize. We showed that FO and RU are parallel. Because their slopes are the same. And FR and OU are not parallel because their slopes are different. Thus, or therefore, thus, FOUR, let me say quadrilateral FOUR. Quadrilateral FOUR is a trapezoid. Okay, again, the hard part here is not the proof, right? It's very easy just finding 4 different slopes. The hard part is kind of resisting what your eye is looking at and making sure that you're validating what you think it is using the information that's given. And while it looks very much like a square, the fact that this point right here, I'm not sure whether you want to say it's this guy's fault or this guy's fault, but the x coordinates here on these two right endpoints are different, and therefore this is not a vertical line, and therefore it's not parallel to this. So it can't be a square. That only leaves a trapezoid, right? So don't just go based on what your eye sees. Make sure that you use the information that's given. Okay, last one. I'm going to switch pencils. Okay, here we go. The vertices of triangle JEN are 210, 6, 4, and 12, 8. Use coordinate geometry to prove that GEN is an isosceles right triangle. This is our first proof that's going to involve a triangle. But again, I feel like the triangles are a lot easier. And we added them to the bottom of our sheet right here. If you remember when we took notes on it right here. So we're going to have to combine the isosceles part and the right triangle part to prove that triangle JEN is isosceles right. Okay, did not give you any x or y coordinates on here, so we're going to have to put them on. So let's look at this. Again, I advise you to not just draw right across the middle. Let's take advantage of what we know about the points to think about where we should place the x and y axis. So notice that my 3 x coordinates are 2, 6, and 12. I don't need any negative x values. So for me to put the y-axis right in the center would be a waste, because then I would only have places for x values over here, and I would have all this dead space here. So I'm going to move the y-coordinate or the y-axis over to this side to give me as much room as possible for my 3 x coordinates of 2, 6, and 12. Likewise, on the y coordinates, we've got 10, 4, and 8. No negative. So if I were to put the x-axis right here, all of this would be wasted space because I don't have any negative y coordinates. So I'm going to move my my x-axis down here to give me as much room in the positive y-axis as possible. And then I just need to get up to 12 here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I'll count by ones, but I'm just going to mark every 2 so I don't have to write as much. So this is 2, 4, 6, 8, 10, 12. And then on the y-axis, I need to go up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's not enough for me to go a second 10. So again, I'll just count by ones, but I'm only going to mark every second one. So 2, 4, 6, 8, 10. If you really want to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's fine. Keep going, but I don't. Okay. So now that we have them, let's plot those points. So this is 2, 10. It's going to go right here. This is point J. And then E is 6, 4. That's right here. Oops. I was going to write the ordered pair, but I think I'm just going to write E. And then N is 12, 8. So 12, 8. That's point N. Okay, so let's connect them, make our triangle. It would be better if you had a ruler, unlike me, because mine is pretty sloppy here. So, all right, now, one thing I can tell you is since they did not tell us which angle is the right angle, we just kind of have to figure that out for ourselves. And hopefully it's not too hard to tell that this is going to be the right angle. All right, so if we're looking for it to be an isosceles right triangle, 2 of the sides are going to be congruent and 1 of the angles is going to be right. And that right angle is going to fall between the 2 congruent sides. So this one is the one that certainly appears to be right. Again, we're not going to just go on that. We're going to prove that it's right. But I'm going to guess that this is the right angle. This certainly looks acute. That looks acute. In fact, they look congruent, which they should be an isosceles. But I'm going to go with that one is right. If that is correct, then these 2 should be the congruent sides. All right, so we would say this and this will have to be congruent. This will not be congruent to them. All right, so in order to show that this is an isosceles right triangle, first of all, we're going to have to show that these 2 sides are perpendicular, which means that we're going to have to find the slope of them. And then the second thing that we're going to have to do is show that these 2 sides are congruent. Technically, that's enough to show that because this one can't possibly be congruent because we can't, that would make it an equilateral. We can't have that. So we're going to just show that these 2 are congruent. That's right. Okay, so, and again, in order to do right, we're going to show that these 2 are opposite reciprocal slopes. So let's do the slope of JE. All right, so I guess I should do that. Let's see, the J and E. So I'm going to take the difference of the y coordinates, so 10 minus 4 over 2 minus 6. All right, that is 6 over negative 4, which is negative 3/2. And then the slope of EN. Right, so I'm going to take the difference of the y coordinates, 8 minus 4 over 12 minus 6. 8 minus 4 is 4. 12 minus 6 is 6. That's 2/3. All right, so let's look at those slopes. In order to be perpendicular, they have to be opposite, which means they have to be the flip of each other. Yes. And, wait, sorry, that was the reciprocal part. The opposite is opposite signs. So this is negative, this is positive, and these are reciprocals. So yes, JE and EN are perpendicular, therefore that's right. Okay, then we have to show that JE and EN are the same distance. So we're going to go with the distance formula. So JE, so I'm going to take the difference of the x coordinates, 6 minus 2 squared, difference of the y, 10 minus 4 squared, add them, put them under the radical sign. 6 minus 2 is 4, and 4 squared is 16, plus 10 minus 4 is 6 squared is 36. Sorry, my battery is showing it's almost dead. That's why I'm kind of going a little bit faster here. That is 52. Again, I don't need you to reduce that. We just need to show that EN is the same length. All right, so we're just going to hope for a square root of 52. Okay, so then EN is difference of the x coordinates, so 12 minus 6 squared, plus difference of the y coordinates, 8 minus 4 squared. 12 minus 6 is 6, squared is 36. 8 minus 4 is 4, squared is 16. So again, we get 36 and 16, which is the square root of 52. So they are congruent. Okay, so we just showed that triangle JEN is isosceles right by showing that angle E is right. The sides that form it are perpendicular. And JE is congruent to EN because their side lengths are equal. Okay, and again, we don't have to show JN is not equal to EN and JE because there's no way it possibly could be. If this is a right angle, there is no way that this could be equal to this, because then we have a hypotenuse because it's a right triangle, and the hypotenuse will always be longer than the leg, so therefore it can't be congruent to the leg. So in another triangle, we would have to show, if we're trying to show isosceles and not equilateral, we would have to look at that third side. But in this case, because we know it's right, we don't have to bother with that side. Okay? Good luck with the other problems. All right, bye.